All right, let's get ready for our navigation test tomorrow. So before we start going through this, let's do a quick recap on what we learned about navigation. The most important thing about navigation is that you know that the north is 0 degrees, east is 90 degrees, south is 180 degrees, and west is 270. So each one of these little quadrants is equal to 90 degrees. So 90 plus 90 is 180, 180 plus 90 is 270, and brings us all the way back up to the top. So on Roman numeral 1, they want us to draw a diagram to show the path of a ship proceeding on the given courses. So if I was going to draw a ship that's going 70 degrees, 70 degrees would be right here between 0 and 90, and it would be 70 from the north. Okay, 150 degrees would be down here at the bottom right between 90 and 180. So from the north, this whole angle would be equal to 150. If we're going to go 340 degrees, 340 would be between 270 and the top. So I draw an angle this direction. And the course or bearing from the north would be a total of 340 degrees. The last one, 225. 225 would be between 180 and 270, so it would be in the bottom left corner. So from the north all the way around would be 225 degrees. On Roman numeral 2, the question says, what is the course in degree for each of the directions below? When they ask you for the course, they're asking you from the measure of the angle from the north. So some of these are real straightforward. If they ask you what is the degree of north, we already talked about that. The degree of north is 0. The degree of south is 180. I'm skipping. The degree of east is 90, and the degree of west is 270. And those are just straight off the compass. The ones that are remaining, the northwest, southeast, northeast, and southwest, all you have to do is add 45. So let's look at what I'm talking about here. So if I asked you to draw northwest, northwest would be the top left. So it would be the angle that goes from the north all the way around. I know 90, 180, 270, plus this little wedge right here. This wedge for northwest cuts the 90 in half, so you just add 45. So if all the way to here is 270 and I add 45, so 270 plus that 45 is going to give me 315 degrees. Okay, let's go look at another one. Let's go look at the one that says southeast. When they ask you to do southeast, you're going to be at the bottom right. So I want this angle from the north all the way to this line. I know this little piece right here is 90. Plus I just cut this in half. So I add 45, and 90 plus 45 is 135 degrees. Number 10, they want me to go northeast. So we're going to be in the top right. And all I have to do is cut this first quadrant in half, and half of 90 is 45. Southwest is going to put me at the bottom left. So it wants this whole entire swish. So I know 90, 180 plus 45. I'm going to go add these together, and I'm going to get 225. So Roman numeral 1, Roman numeral 2 is just about reading off the compass. So 13 through 28 are asking you about different word problems. I'm going to show my work to the side for each one of these on a sticky note as we go. So we're going to look at 13 first. So on 13, it says the ship Time Bandit sights a ship Wizard on a compass bearing of 60 degrees. They want me to make a sketch and give the compass bearing of the Time Bandit from the Wizard. All right, so the first thing I'm going to do is sketch the original problem. So on the original problem, I've got a Time Bandit that's sighting the Wizard on a compass of 60. So I know from what we did earlier that 60 degrees is going to be at the top right. So I'm going to be drawing an arrow going up and to the right. So this is my time bandit. And I'm going to draw, here's my compass, going up and to the right, and they told me it's going to go up and to the right 60 degrees. So that angle right there is 60 degrees. And it's going to sight, if I draw another compass, the wizard. So here's a wizard. So time bandit sights the wizard on an angle of 60 degrees. What they want me to do is they want to know what is the bearing, which means angle, of time bandit from wizard. When you see the word from, that tells you where to start. It says from the wizard. So I go to the north of wizard and I swish around. What I want to know is what is this whole angle measurement from the north. So I know from here to this dot is 180. And then I know because I have alternate interior angles that this wedge right here is 60. So I'm going to go add 180 plus 60. And when I add 180 plus 60, we get 240. So that's my answer for number 13, 240 degrees. Okay, number 14. 14 says, suppose point W is directly west of point Z. What are the bearings from of W from Z? And then part B, what are the bearings of Z from W? All right, so first thing I'm going to do is go draw the picture. They tell me that W is directly west of Z. So W is to the left of Z. So there's my picture. Part A wants me to find the bearing of W from Z. That tells me go start at the Z and swish around until I hit the line. 90, 180, 270. That's part A. 270 degrees. I'm going to go redraw my picture for part B. It's the same picture, W and Z. On part B, they want the bearing of Z from W. So this time they want it from W. So I go to the W, I go to the north, and I switch to the line. Well, that's just 90 degrees. There's 14. All right, 15. 15, we have a jet that flies on a course of 125 degrees at a speed of 1,400 kilometers per hour. How far east of the starting point is the jet after 3 hours? Okay, so let's go draw this picture. We've got a jet on a course of 125 degrees. So let's remember that 125 degrees is going to put me going down and to the right. I'm going to draw my compass, and I'm going to draw something going down and to the right. Now from the north, this whole thing is 125 degrees. But anytime we've done one of these word problems, I've always told you, you've got to find these little wedges. So this is when we use our calculator. I know the whole swish is 125. And I know this first quadrant right here is 90. So I see that my wedge must be 35. Because 90 plus 35 gives me that 125. So this little piece right here is 35. And I'm going to fly along this course at a speed of 1,400 kilometers for 3 hours. So if I want to know this distance right here, I have to take the speed and the time and multiply them. So I'm going to have 1,400 times 3 hours, and I know that this line is 4,200 kilometers long. It wants to know how far east of the starting point I am. So it wants to know this distance. How far east did I go? Well, this gives me a right triangle. If this piece is 35 and this piece is 90, that means my missing piece is 55. And you can choose to do law of sines or SOHCAHTOA. Y'all seem to be more comfortable with law of sines, so that's how I'm going to do this. So I know that I have this angle on this side. So sine of 90 over 4,200 is equal to, I want this side and the angle opposite is 55. Okay, oops, should be x, sorry. And we're going to cross multiply and divide. And remember, when we cross multiply, You're going to look for the numbers that are diagonal. You're going to multiply those together, and then we're going to divide by the one we didn't circle. So in your calculator, you're going to have 4,200 times sine of 55 divided by sine of 90. And the answer is 3,440.44. So 3440.44. Okay, I'll write that down. 3440.44. And I forgot to write the ones down from earlier too. This one was 270, and this one was 90. Okay, all right, so that was number 15. Let's go look at 16. 16 is one of those sighting problems again. We have the bearings. So we have ship calculus, sights, ship statistics on a bearing of 306. What is the bearing of calculus from statistics? So we're going to draw our picture first. This time I'm going to have a bearing of 306. So before I start drawing, I'm going to remember that 306 means I want a line going from bottom to the top left. So I want to probably start my picture down here at the bottom. Okay, and that is calculus, so I'll just label it calc. And ship calc cites statistics on a bearing of 306, which is going to put me right here. And here's my stat ship. Now remember, the whole swish was 306. This entire swish. And I know that this right here is 270. So if I subtract those, I can find this missing piece. Remember, it's always about finding the missing wedges. So I know from the north all the way over here to the west is 270. I need to go a little bit more to go 306. So 306 minus 270 says I went 36 more. So this little inside wedge right here is 36. If this inside wedge is 36, alternate interior angle says this one is 2. They want me to find the bearing of calculus, there's our key word, from statistics. That means go start on the ship that's a stat, put your pencil on the north, and swish clockwise to the line. So I know this first quadrant gives me 90, and I'm going to add my 36. So 90 plus 36 is going to give me 126 degrees. So this is 126 degrees. I'll put that there one more time in case you want to look at it one more time. Okay, 17. A ferry is leaving the dock and proceeds due east for 4 miles. It's then going to change course 195 degrees until it's due south of its dock. How far south is this? Alright, so here's the picture. So here's the dock. And the ferry is going to leave the dock and go east. So that means that's 90 degrees. And it's going to go east for 4 miles. So this distance is 4. Then it says we're going to change course. So remember, every time it says change course, I'm going to draw a new compass. And I'm going to go 195 degrees. Well, I know north to south is 180. So right in here. And I'm going to draw this line until I'm due south of the dock. Alright, so let's talk about wedges again. So I went 195 total. So from here to here is 195. I know north to south is 180. So I want to subtract those to figure out what this wedge was. So I wanted to hit 195. I subtract the 180, and I find out that this little wedge right here is 15. Okay, if this is 15, alternate interior angles, so that this is also 15. I know this is 90, so I should be able to find this missing piece. And find out that missing piece is 75. 75 plus 15 plus 90 adds up to 180. Now, which side do they want to know? Do they want to know the hypotenuse, or do they want to know the vertical side? They want to know how far is the ship from the dock, from right here. So they want to know this distance right here. Again, we can do law of sines or SOHCAHTOA. Again, y'all are better at law of sines, so that's the one I'm going to do. So I have an angle on an opposite side. So sine of 15 over 4 is equal to, I want the x and the angle opposite x is 75. Sine of 75 over x. We're going to multiply the numbers that are diagonal and divide by what I did not circle. So 4 times sine of 75, enter, divided by sine of 15. 14.93. X equals 14.93. Okay, let's go do the next one. Let's go do number 18. All right, 18 is the parallelogram problem. So when you're asked to do the parallelogram problem on the test, the first thing you're going to do is draw a parallelogram. So remember, that's just a rectangle that kind of slants a little bit. And they tell me that one of my angles is 120 degrees. Well, 120 degrees is the obtuse angle. So it means this is 120. So is this. They also tell me that it's 16 by 14. And they want to know how long the diagonals are. So I'm going to use this to be my first diagonal. And I'm going to call it x. I know a side, an angle in the middle, and a side. When you have side, angle, side, and you know the side, the angle, and the side, we're going to use law of cosines. And yes, you have to know your formulas tomorrow. Law of cosine says that x squared will equal these two sides, the sum of their squares, minus 2 times their product, times cosine of that angle in the middle. That's what we're going to type in our calculator. Okay, so here we go. We're going to do 14 squared plus 16 squared minus 2 times 14 times 16 times cosine of 120. And we see this answer pop up. That is not your answer. It will be an answer choice. You have to remember that that's the formula for x squared, so I have to take the square root of my answer. So one of my diagonals will be 26 centimeters. Okay. Now I'm going to go find the other diagonal. When I find the second diagonal, I like to redraw my picture. So I'm going to go redraw the exact same parallelogram. These are still both 14. These are still both 16. I don't want this diagonal this time. I want the one that goes the opposite direction. I want this one. I'll call it y. Because I want this diagonal, I have to go find this missing angle. You are supposed to know that a parallelogram adds up to 360 degrees. And I've already used 120, so I need a minus 120 minus 120. So here we go. 360 minus 120 minus 120 equals 120, but I have to divide that between two angles. So my missing angle is 60. Okay, again, I have a side, an angle in the middle, and a side. Side, angle, side. So I can use this exact same formula. So it's 14 squared plus 16 squared minus 2 times 14 times 16 times cosine of 60. It's the exact same formula we did earlier, except instead of doing 120, I'm going to do 60. So 14 squared plus 16 squared minus 2 times 14 times 16 times cosine of 60. Now I'm going to remember that I have to take the square root, and we get 15.099, so 15.1. So my other answer, I'll write it right here, is y equals 15.1. So my diagonals were 26 and 15.1. Okay, number 19. A ship spots a lighthouse directly north of its position. Ship B, exactly 30 miles west of A, spots the same lighthouse at a bearing of north 40.5 degrees east. Let's look at what this picture would look like. So I know that I have a ship, and I know directly north of it is a lighthouse. Excuse my lighthouse, that's the best I'm going to get. Okay, so there's my lighthouse, and it tells me that directly 30 miles to the west of A is another ship, ship B. And then they tell me that the person on ship B can also see the lighthouse. That's its line of sight. And it tells me the line of sight is north 40.5 degrees east. The 40.5 goes outside this triangle. So alternate interior angles tells me this is also 40.5. I know this is 90 degrees. So I can say 90 minus 40.5. I know this piece in here is 49.5 because these two will add up to 90. Okay, so what do they want to know? They want to know how far the ship A is from the lighthouse, so they want to know this. And they also want to know how far B is from the lighthouse, and we'll call that Y. So I'm going to do law of sines in order to find the answer. I'm going to do it twice, once with the X and once with the Y. So 40.5 is opposite the 30. So sine of 40.5 over 30 is equal to, opposite the X is the 49.5 over X. And we're going to cross multiply and divide. So we're going to have 30 times sine of 49.5, enter, divided by sine of 40.5. So this first distance right here is 30.13. 35.13, sorry. So X is 35.13, the first distance. Okay, and we're going to go find Y, the distance B is from the lighthouse. We're going to use something very similar. We're going to start off with the exact same fraction. Sine of 40.5 over 30 is equal to, opposite the Y is the 90. Okay, we're going to do the same thing in our calculator. We're going to multiply these two and divide by that one. So 30 times sine of 90 divided by sine of 40.5. And we get 46.19. 46.19. Okay. Number 20. Ship Carter sights the ship Laskowski on a compass bearing of 80 degrees. Make a sketch and give the compass bearing of the Carter from Laskowski. Alright, so I have a compass bearing of 80 degrees. So I know this angle is 80. Here's Carter. Up here is Laskowski. Alternate interior angles tells me this wedge is 80. Remember, the key is they ask you what is the compass bearing of Carter. You look after the word from Laskowski. So I put my pencil on the north and I swish all the way around. I know from north to south is 180. And then I'm going to add my alternate interior in 180 plus 80. I'm going to add those together and I'm going to get 260 degrees. 21. A ladder leaning against the wall meets the ground at a point 7 feet from the foot of the wall. If the ladder makes an angle of 70 degrees with the ground, how far up the wall does the ladder reach? Okay, so a ladder is leaning against a wall. So we're going to make this my wall. And here's my ladder leaning against it. So a ladder leaning against the wall meets the ground at a point 7 feet from the foot of the wall. So this is 7 feet. This is a 90-degree angle. If the ladder makes a 70-degree angle, how far up the wall? They want to know this right here on the outside. So if this is 70 and this is 90, this inside piece is 20. So I can do law of sines again. So sine of 20 over 7 is equal to sine of 70 over x. We're going to multiply these two and divide by sine of 20. So 7 times sine of 70 divided by sine of 20 gives me 19.23. Okay, 22. So on 22, it's another bearing problem. This time we have ship pre-cal citing ship geometry with a bearing of 308. Because I have a bearing of 308, my picture needs to start at the bottom. Hopefully you're getting better at this. 308 is going to be in this direction. Pre-cal cites geometry on a bearing of 308. So again, I know that from the north to the west is 270, but I know I need to go 308. So I have to subtract 308 and 270, and I get 38. So this little wedge is 38. Alternate interior angles tells me this is also 38. The problem wants the bearing of pre-cal from keyword geometry. So I start at the north pole, and I swish clockwise to the line. I know first quadrant is 90, so I do 90 plus 38, and I get 128 degrees. So the answer is 128 degrees. All right, 23. A hiker spots a safe house directly north of its position. So I've got this hiker. This is hiker 1, and directly north, which means this is 90, there's a safe house. Okay. Then it tells me that a second hiker exactly 2 kilometers to the west of the first, so this direction would be west. This is hiker number 2. Also cites the same safe house. Here's my line of sight. And it tells me that my line of sight is 41.2 northeast. That means this 41.2 is right here outside the triangle. So if this is 41.2, alternate interior angle says this one is 2. And I can see that my inside is going to be 48.8 right here, because I need this whole thing to be 90. So 48.8. Okay, so they want to know how far is the first hiker from the safe house. They want to know that. And they also, part B, wants to know how far the second one is. So we'll call that one Y. So by now, hopefully you can look at this and go, oh, it's just another law of sines. So let's go find X first. Opposite the X is the 48.8. And opposite the 2 is the 41.2. So sine of 41.2 over 2 is equal to sine of 48.8 over X. And then we're going to cross multiply again. So 2 times sine of 48.8 divided by sine of 41.2. We find out the first hiker is 2.28 from the safe house. Let's go find the second one. Here's the second hiker. Let's go find Y. We're going to start off with the same fraction. Sine of 41.2 over 2 is equal to, opposite the Y is this 90. So sine of 90 over Y. We're going to multiply these two and divide by sine of 41.2. So 2 times sine of 90 divided by sine of 41.2. And we find out the second hiker is 3.04. kilometers from the safe house. Okay, we're almost done. We only got a few more left. 25. A 747 flies on a course of 110 degrees at a speed of 1,200 kilometers per hour. How far east of the starting point is the 747 after 2 hours? So 110 degrees is going to put me close to the 90. what I want to know is, what is my wedge? So I know the whole thing is 110. And I know this piece is 90. So what do I have to add to 90 to get 110? So 110 minus 90. Oh, that little wedge is 20. So this little piece in here is 20. And it says that I'm going to be going 1,200 kilometers per hour for 2 hours. So if I multiply the speed times the time, I can find out that this distance is going to be 2,400. And they want to know, how far east am I of my starting point? They want this. They want x. So 90, 20, that means this angle is 70. And again, same old, law of sines. So sine of 90 over 2,400 is equal to, if I want x, I have to use which angle? Which one's the opposite? The 70. We're going to cross multiply these two and divide by sine of 90. Okay, so 2,400 times sine of 70 divided by sine of 90. And the answer is 2255.26. A pole leaning against a wall meets the ground 12 feet from the foot of the wall. Okay, so I've got a pole leaning against a wall. So here's my wall. Here's my pole leaning against it. It says that it's 12 feet from the wall. So this is 12. That makes that 90. It says the pole makes an angle of 70 degrees with the ground, which means this is 20 because I have to add up to 180. And they want to know how far up the wall the pole reaches. So they want this. Again, I've got a law of sines, nice and easy. So I have angle 20, opposite side 12. So sine of 20 over 12 is equal to, I want x and its opposite 70. We're going to multiply these two and divide by sine of 20. So 12 times sine of 70 divided by sine of 20. And we get 32.97. 32.97 feet. Alright, two more. Got another parallelogram problem to go try. So a parallelogram has an angle of 70 degrees and has sides that are 10 by 6. How long are the diagonals? Alright, so again, first thing I'm going to do is draw my parallelogram. I know that the acute angles are both 70. I know that two sides are 10 and two sides are 6. And I'm going to go find that diagonal there. I'm going to call it x. We're going to use our law of cosines. So 6 squared plus 10 squared minus 2 times 6 times 10 times cosine of 70. Don't forget to take the square root. So 6 squared plus 10 squared minus 2 times 6 times 10 times cosine of 70. And we're going to square root that answer. And we're going to get 9.74. So one of our answers is 9.74. Now we're going to go find the second diagonal. And again, I'm going to redraw the picture. Okay. So I still know that both these sides are 6. The tops and bottom are both 10. But now I want this diagonal. I'll call it y. I already know that 70 plus 70 is 140. And a parallelogram has to add up to 360, which leaves me with 220 left to split between two. That means that each angle is 110. This is 110. I'm going to use the exact same formula I did up here. 6 squared plus 10 squared minus 2 times the sides. But this time, instead of doing cosine of 70, my angle is 110. And I have to remember to take the square root. So we're going to do 6 squared plus 10 squared minus 2 times 6 times 10 times cosine of 110. And then I'm going to square root it. And we get 13 0.31. Alright, last problem, number 28. A cruise ship leaves dock and proceeds due east for 2 miles. So I'm going to leave the dock and I'm going to go east for 2 miles. And then I'm going to change course. So I'm going to draw a compass and I'm going to go 205. Well, north to south is 180. So I'm going to go past the 180 and I'm going to draw that line until I'm directly due south of the dock. Okay? So we have to find this wedge again. So from north to south, I know that piece right here was 180, plus this wedge gives me 205. So 205 minus 180 tells me that wedge right here is 25. If this wedge is 25, so is this inside angle. I know that this is a right angle. So 90 minus 25 tells me that this piece would be 65. They want to know how far south I am. So again, I see a law of sines. I see that 65 is opposite the x and 25 is opposite the 2. So sine of 25 over 2 is equal to sine of 65 over x. I'm going to multiply these two numbers diagonally and divide by sine of 25. So 2 times sine of 65 divided by sine of 25. And we find out it's 4.29. Okay, so that's the review sheet, and may need to watch it a couple times, maybe pause it, redo a couple of the problems that you're having trouble on, study tonight, and I'll see y'all tomorrow. Good luck.